How you doing, guys? In this video, we're gonna look at a example that we're gonna use the ideal gas law to solve. There's a couple of things that you need to keep in mind when you're gonna use the ideal gas law, and it's usually remembering what units to actually use. You are going to come across some problems where you're going to have different kinds of units, but to use this method effectively, you have to be using the proper unit, so you will have to convert. And just to show you right up here, our ideal gas law is PV equals nRT. And the constant that we're going to be using is R, and I'm showing you guys what R is, also because the units are crucial to using this method, and the fact that we're going to be using this specific R because there are different kinds of R's. Not different kinds of R's, but there's different meanings to R in chemistry. Well, let's go back down here. First, what we want to do, number one, is make sure that we're going to be in the right, that we're going to actually be using the right units. So as we go through, let's read. Calculate the volume. See, there is what we're going to be calculating for, is the volume. Occupied by 0.973 moles of nitrogen gas at a pressure of 1.42 atmospheres and a temperature of 36 degrees Celsius. Our first step that we're going to do is we need to convert whatever we have to the proper units. Now, our units will consist of this. We will be using liters, we need atmospheres, we need moles, and we need Kelvin. Now, as we go down and read through this question, we have moles, we have atmospheres, we're solving for volume, which is going to call for liters. The only thing that we have to convert is this here, 36 degrees Celsius to Kelvin. To do that, we're going to do 36 degrees Celsius plus 273.15. And that is going to give us, let me calculate this because I'm doing this along with you guys, 36 plus 273.15. And that gives us 309.15 Kelvin. Well, now that we got that out of the way, now let's put this equation in terms of what we're actually going to be solving for. We have PV equals nRT right here. So let's rewrite this. PV equals nRT. Now I'm going to do this calculation just for the people that aren't really used to seeing things worked out this way. A lot of people just sometimes measure it, or not measure it, sorry, remember it. We're solving for volume. So what we need to do, we're going to divide P to both sides, and that's going to give us V equals nRT over P. So this is the format of the equation that we're going to be using. So now let's scroll back down here and let's rewrite this. V equals nRT over P. Now, from this point, all of our units check out, because if we look at our constant, the units for that is liters times atmospheres over moles times Kelvin. So once we plug this in, let's go ahead and do this. We have moles, so that will be 0.973 moles. I'll separate it out for you guys. Times our constant, 0.08206 liters times atmosphere over moles times Kelvin times temperature, which we converted to this. So now we will be using this temperature, 309.15 Kelvin. And as I'm writing this, you can start seeing what units will be reducing. Over 1.42 atmospheres. So now that we got to this point, it's obvious that this is just the part where we multiply the top and divide it by the denominator, sorry. But what's important to understand is you see the pathway of how we're going to get the appropriate units for what we're solving for, which is volume. Moles reduce, Kelvin reduces, and atmospheres reduce. So now we are left with liters. So this, now we're solving for our volume. Our volume equals, and let me punch this in the calculator too. We have 0.973 times 0.08206 times 309.15 divided by 1.42. Now let me just make sure that I did this correctly. Okay. Our answer for our volume is 17.38 liters. Now, for this, I didn't exactly take into consideration the significant figures, but just by a quick eye here, I believe we'll be using 3, so we will probably be getting 17.4 liters. And this was a way to solve a problem using the ideal gas law.